everyone. Welcome to another live session at the Reactors. My name is Rav, and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way you engage. This session will be recorded and will be available to view on our Reactor YouTube channel within the next 24 hours. Today's episode is on continuous security in an Azure DevOps pipeline. The session will be led by David, who is an Azure MVP and a cloud security consultant. The chat will be open throughout, and we do encourage you all to participate. And with that, I'm going to hand over to David, who will now take the session.
Hello, hi. Are you able to hear me?
Yes, David, perfectly.
Awesome. Yeah, so I'm sharing my screen also. Is my screen coming to awesome? Yeah, I can see that. So I'll go ahead and share my camera also. So awesome. Yep. So hello, everyone. So welcome to this session on continuous security in an Azure DevOps pipeline. So thanks very much, Val, for that lovely introduction. And thanks very much for the for setting up the session and for putting everything together. So as I've said, my name is David Okeyode. So I am a Microsoft Azure MVP. I also am constantly in the Azure communities, and I like learning about Azure. I like sharing my knowledge with others around Azure. I have a blog that I have two blogs that I maintain. So I have the one for azurehangout.com, but I also have the David Okeyode, essentially my name, .medium.com, right? So you can check that out also. Okay, so let's get started into this. So actually, before I go too far ahead, I have written two books on Azure security. So one I co-wrote with Carl. So Carl is a security researcher. He heads a security team out of Oregon. So we co-wrote a book on penetration testing Azure for ethical hackers, which has practical examples of how to exploit various misconfigurations on the Azure platform. So just check that out. And I also have another book on Azure security, Microsoft Azure Security Technologies, so which goes into a lot more details on how to secure your Azure platform using some of the cloud-native security capabilities and additional capabilities that you can leverage to ensure that you keep attackers out of your environment or you minimize risks to your environment. So check out the two books. So in terms of today, we're going to be looking at how do we provide automated security on a continuous basis in our Azure pipelines, right? So, and I'll be doing a little bit of whiteboarding. I'll be doing a little bit of slides, and I'll be doing some demonstrations. So I'll be going back and forth a little bit. If you do have any questions, feel free to put them in the chat window, and I'll be happy to address the question at the end of the session. So organizations do have a requirement to deliver innovation at a quicker pace into this world. So organizations have that requirement. They need to be able to leverage technology to show that differentiation between them and their competitors. And part of that is being able to deliver value to customers on a continuous basis. Now, in order for organizations to be able to do that, the traditional approach of releasing software, traditional approach of releasing technology value, that traditional approach no longer works, right? If you have that sort of requirements, that traditional approach no longer works. So the traditional approach where you have that organization boundary between the dev team and the ops team, where everyone is sort of like aligned to their own separate processes and doing things their own way, and it's not really allowing the organization to streamline their processes and being able to move at a faster pace, right? So it leads to the typical problem that we see of where dev teams are like, yeah, everything worked well in dev. It's the ops team's problem now. You go ahead and you tackle that. It's up to you to handle. So that approach no longer helps organizations. So organizations are adopting a different approach, and as part of adopting a different approach to meet business requirements comes the adoption of new technologies, right? But it's not just about the technology, it's also about the organization change. Organizations are also looking at how they've structured their teams. So in some cases, development teams are becoming much more full stack team, but also from the perspective of having much more vertical teams that spans across the software architecture versus horizontal teams that are just focused on just maybe a layer of the software architecture, like where you have like your front-end team, your mid-tier team, and your dev team. So that's quickly changing to where you have feature teams, where a team focuses on a feature or a component of a product as a microservice. They can quickly develop that, quickly innovate on the development, and quickly release that, and sharing the expertise from different sections of the members of the team, right? So we're having increased technology change and increased organization change. But I want to talk a little bit about this term cloud native before I move too far ahead, because I realize that that's a term that can be confusing to a few people when you talk about that. Again, depending on your experience level. So when we say cloud native, really it doesn't really have much to do with cloud or cloud as people may think about cloud, right? People think about cloud, you're thinking about platforms like Azure, AWS, GCP, and other clouds like that. Cloud native is really talking about a set of technologies. So it's not really just talking about cloud in that way. So Microsoft has a nice document that goes into a lot of details on that. And in that document, which I'll put the link to the document on the screen. So, and actually, no, this is from the cloud native, but Microsoft themselves have a link to another document, which I'll add the link for you later. So cloud native is defined as technologies that empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid cloud. So that's the CNCF definition of what cloud native means. And if you have a look at this definition, it's really nothing, again, specific to do with a particular cloud platform. It's really talking about modern technologies that allows us to be able to develop, build, and deploy very quickly and at scale. So you're talking about technologies like containers, you're talking about technologies like implementing microservices versus monolithic architectures. You're talking about technologies like service mesh, immutable infrastructure, to where you're having just rolling updates of your infrastructure versus having to be troubleshooting in production, and technologies like declarative APIs. All these are technologies that you classify as cloud native technologies. And these are technologies that organizations are adopting to be able to move at pace, to be able to deliver the rate of innovation that they need to be able to deliver. Again, check out that definition. Check out the link on the chat window for more of that. But as part of that also, the cloud is an important part of that, right? So the Azure cloud is an important part of that. The Azure cloud is, my own personal favorite cloud platform. So, and that talks about the different services that we can use in the cloud. So like the Azure cloud has about 175 or more services that exist on the platform. And, we are having other stuff where we have like maybe single host container technology and maybe orchestrator technology services like Azure Kubernetes Service, Azure Red Hat OpenShift, and Service Fabric. And we're able to leverage these technologies again to adopt cloud native using services on the Azure platform. But as part of this, we have challenges, right? So we have security challenges of cloud native. So one of the chief security challenges, by the way, so credit to Peter Cheslock for this diagram. It's a very interesting diagram because it shows some of the challenges that we face. Now we're talking about pace, we're talking about the rate of innovation, but there are security issues that comes as a byproduct of that organizations in some cases are still struggling to address that. How do you address these challenges? Let me give you an example of what I'm talking about. So I was going to bring up a document on the Azure, just Microsoft Cloud Native. So I want to show you an example of what I'm talking about. So Microsoft Cloud Native document. And I will bring up this document on the screen for you to review. So let's see. This document on cloud native applications. Let's go ahead and find this document. So just 1 minute, apologies. So bringing up that document, let's see, got it. Okay, so if you look at this document, so this document talks about what is cloud native. So it's a document that you can find on docs.microsoft.com. And it talks about what is cloud native. But if you scroll down in this document, I really like this as a good example. If you have a look at this, you have a company like Netflix that's adopting cloud native technologies to move at pace. And they
Sorry,
have,
David, did you want to share your screen?
oh, am I not sharing my
Yeah.
screen? Sorry about that.
No
Apologies
problem.
for that. Sorry about that. So let's go to share my screen again. And let's do that again. So let's go to that. Can you see my screen now?
Yes, we can.
Awesome. Yeah, sorry about that. So I thought I was sharing my screen. So there you go. So that was what I was talking about. So you have a company like Netflix, for example, right? So this is a document that I'm sharing. So it's from Microsoft, docs.microsoft.com. So giving examples of cloud native implementations and companies that are adopting that. So if you have a look at something like a company like Netflix, they have over 600 services in production and they're deploying 100 times a day. If you have a look at a company like Uber, they have about 1,000 plus services in production and they're deploying several thousand times a week. You have a look at a company like WeChat, they have over 3,000 services in production and they're deploying thousands of times a day. How do you implement security at this scale? That's a big challenge. You can't afford to be like a gating mechanism at the end of the process. Are you going to be reviewing every 100 changes that's happening every day? How many security engineers and architects do you need to be able to handle that level of scale, right? And by the way, every time a deployment goes out, it has a potential of impacting the risk posture of the organization. So these are not like armless deployment. In some cases, people that are doing the deployment have no idea what risk they could be introducing with the deployments that they're doing. So how do you handle security at this scale, right? So that's one of the security challenges that we're talking about here. So DevOps workflows are heavily automated, and in many cases, for many organizations, security checks for applications and infrastructure code, a lot of those security checks are still relatively manual, which means they're not able to scale, which means they're probably dropping the ball somewhere. So DevOps and security teams are also measured differently, right? So in many cases, the security team are measured on the risks that they can reduce from being introduced into the environment, while DevOps team are measured on being able to move at pace and develop and innovate quickly and deploy quickly, right? So now you have like potentially two conflicting goals. While one team is trying to reduce the risk, the other team is trying to move at pace. And then in some cases, I had somebody talk to me at one of the user groups that I attended one day, and the person said, everything else that we do in our dev team, everything is all automated until you security people get involved. And then everything becomes like a painful process at that point, right? You're really causing troubles to us. So part of the reason is because organizations have not aligned their processes and aligned their internal metrics to where they are measuring the security team and the DevOps team on a common goal, right? So there's a cultural aspect to this. It's not just about the technology. It's also like about aligning your processes and aligning the metrics that you use for that. So changes that impact on security posture happens continuously, right? That signifies the diagram that you have on the screen. Changes that impact security posture happens continuously. Security trying to do cleanup afterwards. Everybody's all tired, right? So, and that's the example that I gave to you on the screen right there. So, and I also like this other one because that's another set of security challenges that we have, is that when you're moving at the pace of DevOps, you're also accelerating this delivery to production in many cases. I like this quote from DevOps Bharat. Fortunately, the account is no longer active on Twitter, but it says to make error is human, to propagate error to all server in automatic way is DevOps, right? So isn't that the case where you're accelerating delivery, and in many cases, the people that are accelerating the delivery have no idea from a security perspective now what they're introducing, and in many cases, you end up with so many risks in production. So, and also in terms of trying to speed up delivery, in some cases, people cut out important processes and people cut out important validation that they should be doing in order to be able to meet the release cadence. Okay, we've got to be able to meet the release deadline that we have for this, and therefore we're going to cut out some of these processes just to get that out there, right? And then the other issue is that dev and ops teams are not security experts. Right, so those are two different set of skills, right? The skill to be a DevOps, someone who will understand devs and ops, that's a completely different skill set. from security skill set. And only very few people can manage a combination of both skills at a really high level. So those are part of the challenges that organizations have to solve for. So let me go back to the slide and bring up a different slide here. Okay. So, and what that leads to, it leads to like where organizations have a status quo of security, right? So where organizations have a typical organization, for every 100 developers that they have 10 operations person and 1 security person. And that leads to a status quo, like from what Google has in their document on the State of DevOps reports in 2019, where they highlighted among organizations, how are you doing your DevOps processes? How is it going? And you see that a lot of organizations have gotten really good at automating their build. They have gotten really good at automating their tests, like with their unit test and their functional test and their user acceptance test. They're really good at automating their performance tests. But when it gets to like the security test, you have a very low cost there. Sorry, a very low score there, where they have just about 31% of organization really going, yeah, you know what, we're doing something in that area, right? And actually, if you look at everything, like it's a really, really small number of organizations that says automated security check is an important part of our DevOps process, and we're really able to implement that. So that's another issue there. The other issue is that attack rates are multiplying and increasing. Just take the attack matrix for the Azure platform alone and the different methods and different paths that an attacker can take to exploit misconfigurations and issues in the environment that's growing all the time. And it's the same for technologies like containerization, where the attack rate is increasing. So one of the things that needs to happen for many organizations is that in their DevOps pipeline, they really need to start having a look at how do we automate security all the way from the design stage all the way to the runtime stage, because that's the only way for security to work at scale. Security cannot work implementing a traditional process where you're just relying on your SOC to detect issues and trying to remediate issues once they've happened. That's not going to work at the scale that we're talking about. So here's some of the design patterns or some of the considerations for things to put in place from the design stage all the way to the runtime stage. And then I'll show you like an example of this implementation that I'm talking about in an Azure DevOps pipeline, so you can see that in action. So on the design stage, you want to have security involved right from that very stage. How do you have security involved at the design stage? When teams are thinking about a software architecture, you make sure that security expertise is included in those conversations, right? So you bring someone who understands how to assess risks for different architecture, understanding the concept of risks and threats, and bring them into that conversation so things can be pointed out and dealt with right from the design stage, right? So you want to shift left expertise in your design stage. So that's very, very important. You also want to, at that stage, begin to define roles. Who will be responsible for writing policies that will be using to secure this architecture that we're thinking of coming up with? Will you be responsible for that as the application team, or the security team be responsible for that? If they're responsible for that, how do they feed that into you so you can make use of that in your pipeline? Then we are going to something like the build stage. So this is where you're taking your application and you're building your application. And you want to make sure that you have security embedded in that stage also. That means before code is committed from the developer system into source control, that's been validated and assessed using different processes. Maybe that's vulnerability validation and assessment. Maybe that has to do with software licensing and compliance assessments, and you have that as part of that stage. But don't forget your infrastructure also at that stage, because when you're talking about DevOps and the processes that we're doing, everything is code these days, and you have different types of code. And if you want to be holistic in including security in your pipeline, you have to look at all the types of code, right? You have your application code, right? You have your infrastructure code, right? And infrastructure code can be two types. You have your infrastructure code for the cloud platform, right? So for example, if you're implementing, if you're using the Azure cloud platform, you have your infrastructure code like Azure Ham templates or your Bicep templates, right? And when it comes to infrastructure code, you can also have infrastructure code from the container side. So maybe infrastructure code that they're using to build your container image. So maybe something like your Docker file, right? And maybe things like your Helm charts that you're using to automate the deployment of your solutions in an orchestrated container cluster. Or maybe you have things like your Kubernetes manifest file, right? Your Kubernetes manifest file. So you have to have a look at all of these aspects. And you have to have a look at how do I have security for all these types of code that we're running through our pipeline and that we're building and we're validating and we're deploying through our pipeline. How do I make sure that security test is all automated for all these types of code? So that becomes important when you're looking at things to include in your build stage. And this is especially important because if you miss anything in the build stage, the cost of addressing those issues that are created increases significantly once it gets past the build stage, right? So this is from research from the Ponemon Institute research. And once the issue gets past the build stage and it goes into the QA stage, if you detect any issue at that stage, that has a significant cost to the organization, not just from maybe other issues relating to the reputation of the organization and everything. This can actually slow down your processes because in many cases, the team that are doing the development, they've moved on to other work that they're doing. So now they have to switch their context between what they are currently doing, and they have to switch their context back when security team returns about 500 tickets to them and say, you have to go address this 500 tickets because of all these issues that we've been able to find here. Right. So what you want to do ideally is you want to make sure that you can catch majority of the issues. I'll say about 20%, about 80% of the issues that you're getting should be caught at the build stage, right? And then just only for the things that you need to maybe have in an environment or maybe much more complex issues that you have to be remediating later. So you want to make sure that you catch things as quickly as possible. So then you go to like the test stage. So in things like the test stage, you want to ensure that your pipeline verifies all aspects. That includes the libraries you're using, the images that you're using for your base images in your container images, your policies, your infrastructure as code, your API security rules. If you're deploying APIs into services like Azure Function Hubs, right? You're checking for issues relating to vulnerabilities and malware, right? So, and then you want to ensure that you have policies in place to prevent people from being able to disable security checks. That is important because in some cases, again, in order to be able to get past the deadline, people disable the check, just let it get past the deadline. We'll come to that later. So you want to ensure that has if that needs to happen, that's something that goes through an approval stage where it's not as if people are able to just disable critical security steps in their organization. So there are different ways to apply those types of things in Azure DevOps. Maybe using things like task groups and using things like templates and having your role-based access control configured properly, right? So that's important at that stage. So that's the test. Then for the deployment stage, right? So before you deploy, because vulnerability information changes all the time, you're checking, is there any new vulnerability that has happened since build time before I go ahead and I deploy this? So for example, that may be checking your images in the container registry, right? The image that I have in the container registry, is there any new vulnerabilities that's been announced since it's been published into the registry that I need to address, right? And you're checking some of those issues at that stage. In the operation stage, you want to ensure that you have runtime security still going. So that's still important. The fact that you're automating all these checks does not mean that you let go of normal security best practices, like making sure that your runtime and operational environment is properly secured. So that's really important to know that. So for example, the 0 day that happened with last year, the big one that happened with is SolarWinds. Yeah, the big one that happened with SolarWinds with the supply chain attack. Only organizations that had strong runtime anomaly detection capabilities were really able to stop that, because this was software components that was coming from a trusted vendor, right? that's not really classified as malware by any of the other tools and potentially scaled through a lot of organizations in terms of the checks and everything that they have. Only if you have something like runtime security checks that's looking for strange or unusual behaviors at runtime, will you be able to identify that this is trying to do something unusual and then be able to terminate or block that process. So because you're applying DevSecOps or you're applying security practices, and shifting that to the left does not mean you let go of some of these other security practices around runtime security, right? And that includes things like making sure that you're still doing like your passive and active pen test, and making sure that you're still checking for unusual network activities, making sure that you're checking for any anomalies in the information that you're getting. So here is an example that I will be showing you in a demo environment in a minute. And what this is really looking at is it's looking at, this is from the My Azure Architecture Center. It's looking at the process for getting containers, for example, housed to Azure. So that is what this is looking at. And what we're talking about here is you want to ensure that at every stage, whether at the development loop or at the deployment loop later. So actually I have another diagram that talks about that. So whether at the development loop or at the deployment loop, you want to ensure that you have security as part of the check. So for example, maybe you're authoring your code using GitHub Codespaces with Visual Studio Code, and you push that into source control, whether with Azure repos or with GitHub repos, whichever of Microsoft development platform that you're currently adopting in your organization. At that point, you want to make sure that you had checks at those points. So at the point before that's going to be pushed to the origin source control, you want to ensure that you have all types of checks there for application code, infrastructure code, and your configuration code, right? And that's part of like your development loop. And when you're running like the build, before you publish your artifact, you have more checks and security assessments that you have as part of like the build pipeline. And any issues that's detected, you're raising issues in maybe Azure Bots or GitHub project, again, depending on the solution that you're using. And also when it comes to like the development loop, in your development pipeline, you're also making sure that you're adding those additional checks that I highlighted in those slides. You're adding some of those additional checks at that level, right? Before that gets deployed into your container services. And then once things are deployed to your container services, it's still important to have like your runtime checks going. So whether you're using an orchestrated container services like Kubernetes service, whether you're using a service like Azure Function Hub, Azure Container Instance, yes, you can have runtime protection for Azure Container Instance using solutions that support things like, maybe embedded security solution to ensure that you can stop unusual processes from running within your container instance. So you have all of those checks going. And of course, after you finish building, when you publish that to things like your container registry, you want to ensure that you're checking your container images on an ongoing basis in the registry to be able to detect new vulnerabilities and ensure that only clean images are allowed to the deployment loop into your runtime environment. So here's an example of different checks that you can put in that step. So here's a link to a nice Microsoft document that covers some of the checks that you can put in place from that perspective, right? So, but apart from this, you're also talking about different types of workload services in Azure, right? You're talking about not just container workloads, you're talking about just code, you're talking about using things like virtual machines. So you have checks at every one of those stages. And also when it comes to the posture management, right? You're creating you're deploying services into your Azure environment using Helm templates, using Bicep, using Terraform, and you're ensuring that you're adding security checks at every one of those levels. And you want to ideally catch about 80% of the issue before they get all the way to production. So enough of talking here. Let me go to show you like a demo aspect of that. So what I have over here is I have an Azure DevOps pipeline. So let me bring that up. And I have an Azure DevOps pipeline here. So let me check that. And let me show what I have in this pipeline to you very quickly. So before I go to further ahead, let me go ahead and bring up, show you what the pipeline looks like. So this pipeline has certain security checks that I've baked in at different stages, right? What security checks have you baked in? Well, let me show you some of them very quickly. So, and I'll show you a demo of that. So here's a demo. So here's a visualization of the security checks that we have in place. So I have a pre-commit stage. I have this pipeline broken into 4 stages. So I have a pre-commit stage, a commit and build stage, a deploy stage, and an operate and secure stage. And here are all the checks that I've added in this pipeline. So, and I'm using a combination of Prisma Cloud and Bridgecrew in terms of some of the capabilities that I'm using here, but everything is all running on Azure DevOps platform. So from a pre-commit stage, I'm having, so from pre-commit stage, you have like your infrastructure as code scan and fix check. You have your pre-commit hooks that you're using for infrastructure as code assessment. From local development system, you can implement things like local code repository scan. So there are different tools that you can use for that. For Docker files that developers are using to build the container images, you're implementing Docker file scan there. And you're also making sure that you're assessing the application and the dependencies that are in the base images that you're using. Now, when it comes to the commit and build stage, before we start to build the application itself, we do an assessment of the code itself. So we check the code, we check for issues relating to security in the code, and then we also check the dependencies or the packages that the code is using, right? And we check that, and in some cases, you can automatically fix some of those. So some of you know of tools like Dependabot in GitHub. So for the Docker file and for the stage, before I go ahead and I build the container image, using the Docker file, I'm going to assess the configuration of that Docker file, and I'm going to check whether it's been configured correctly. I'm going to check the base image that it's using, and I'm going to be doing that using a tool called Checkov to check both at that stage. So once the container image has finished building, before pushing that into the registry, I want to make sure that only images that pass security checks are allowed into my container registry. So I do a pre-registry check there. So here, what I also want to do is that any containers that I'm building in my pipeline that's going to end up in a service like Azure Container Instance at runtime, I want to ensure that I have embedded security for them so I can have runtime security even in a serverless environment like Azure Function or Azure Container Instance. So I'm going to be embedding like some form of defender into those before they get to runtime. So now for the deployment stage, I'm going to be looking at the infrastructure as code that's being used to deploy the resources in the environment. So I'm looking at the Terraform template, and I'm analyzing that for security and compliance issues. I'm looking at the Azure Ham template. I'm analyzing that for security and compliance issues. You can add another one for if you're using Bicep templates to do the analysis. There's a Kubernetes manifest file that will be used to provision the services that will be running. I'm having a look to check for security and compliance issues at that stage. Are they running with overprivileged permissions? I'm going to be checking for all those issues. And again, for this, I'm going to be using the same tool that I'm using for this one, which is the tool Checkov, is what I'm going to be using for those, right? And before I deploy any container image to runtime, I'm going to make sure that I check the latest results of the scan in the container registry, and I'm going to check that before I go ahead and I deploy that. So, and then at runtime, what I'm also doing here is I have configuration as code that's been created and committed to source control. So in this particular case, that's assuming that the application team are creating the security policies that will be used to secure their applications at runtime. And before the application actually gets applied, it's going to apply the runtime policies to secure the application, including things like web and API security policies, and then it's going to deploy the application to that runtime environment. So if I go back to this, let me show you an example of that in action. So if you have a look at some of these stages, so if I go to the pre-build stage, I have a check there in the pre-build stage where I'm going to be installing a tool called TwistCLI. That's a tool that I'm going to be using to scan for the code repositories. So that's provided by Twistlock from Prisma Cloud. So, and I have a script there in source control that I'm going to use to install that tool on the build agent. And if I go to the next step after that, let me go ahead and maximize this a little bit more. So if I go to the next step after that, so I have a pre-built check one, so where I'm going to be checking the code repo, and I have, again, a script that's going to be using TwistCLI to check the code repo. So there I'm going to identify any security or vulnerability issues in that code repo. And for the Docker file that's going to be used, I mentioned that I'm using a tool called Chekhov. So Chekhov is going to be running as a Docker container. So I'm going to get Chekhov, and I'm going to get it to run against the Docker file, detect security and compliance issues. And at any of the steps, if any issue crosses the threshold of what I want to allow into runtime, I can stop the pipeline at any of that stage in an automated form. So, and then you get to the build stage, and with the build stage, the application is being built. So this is a Java application. So we build the application, and then we use the Docker file, and then we use that to containerize that application. But before we do that, what I'm going to be doing in this stage is I'm going to be ensuring that the image is going to be assessed and scanned before being pushed to the container registry. So that's what I'm doing here. So scan the image, check for other security issues before you push it into the registry. If it passes the check, go ahead and push it into the registry. And once it gets into the registry, ongoing scan is going to be running against that image. Now, for the pre-deployment stage, that's where I get into my infrastructure as code. And in this case, I'm using Terraform to provision some storage services. I'm using Azure Ham template to provision some SQL services. And then it's going to run assessment against those templates. And if any critical violation is detected, it's going to stop the pipeline at that stage, right? And then we go over to like the check. So before I go ahead and I deploy an image from the container registry, I'm going to go ahead and get the latest results and check that. If that check passes, then I'm going to go ahead and deploy that to runtime. So I'm going to deploy the security policy that's going to be used to protect that. Then I'm going to deploy the app to production. So this takes a short while to run. So instead of running all of that manually, what I'm going to do is I'm going to show you a previous run. And I'm going to bring those 4 stages up. So I have the pre-build stage, the pre-build stage, the pre-deploy stage, and the deployed stage. So let me go ahead and show that to you. So if I click on that, so that's the point where I download and install Twist CLI that I'm going to be using for some of the checks. And then I'm scanning the code repo at that stage. And at none of these points do I have to switch context. At none of these points do I have to bounce to another tool. All of this is within my Azure DevOps pipeline. And within my Azure DevOps pipeline, now within this particular code repo, there's some issues that have been found. So there is a high severity issues with the license of some of the packages that I'm using in that code. So normally you would fail the pipeline at that point. But in this particular case, just for the demo, I have flags that I use in my pipeline when I'm doing the demo. So I just set the flag to false so that I can proceed and show you the rest of the demo. So that's why it's not failed the pipeline, because what I do is I have different flags that I can use to set some steps to say, soft fail it, don't go ahead and don't stop the pipeline. So those are some of the things that you can use to control that, to make sure that people cannot soft fail or disable certain security checks in your pipeline. So let me go back to what I was showing you. So at that stage, I can go ahead and I can fail that because there were some high severity issues relating to the compliance of some of the packages that I'm using. But in this particular case, I like that to proceed. So then the Docker file that's going to be used to build the Docker image, again, pulls Chekhov down, uses Chekhov to scan that. And as it detected any issues with that, so it found certain issues with that failed, right? It says the last user is root that was used, so that's not good. You're exposing port 22. Why do you need to expose port 22 if it's just an application and a service that's running on that image? So it flagged that as an issue. It also flagged other issues relating to some of the configurations. So for example, in this case, I'm exposing a RSA key. I'm exposing that in that image, so it's automatically detected those issues. And at that point, I can fill the pipeline, and that will give links to go address that issues before you proceed. But again, I've set the flag to allow that to proceed. So now if I go to the build stage, so the build stage is where I've got like this stuff. So if I go to the build stage, we build the application, we check out the code, we build the application, and then we containerize the application using a Docker Compose task. But after containerizing the application, before pushing it into the registry, let's make sure that we are pushing a clean image. So let's assess that image. So in this particular case, it's using a policy that's been set up at the organization level. So if I go to like the console over here, I've set up a policy at the organization level, and that's the policy that it's using to do the scan. And then it found that this container image violates an organization policy, and it flagged out the issues, 96 vulnerabilities, and 15 of those are high vulnerabilities. And what I've set in my policy is I've said anything that has high vulnerability should fill the pipeline. So that's that. Normally that will fill the pipeline, but again, I'm using the flag to proceed so the pipeline doesn't stop. So if I go over to this environment, I'll show you where I've configured the organization level policies. And I can have different policies for different pipelines in my organization. So if I go ahead and I bring that up, come on. So, okay, so if I go to under defense section, if I go to under vulnerability section, so I have that organization CI image vulnerability policy. Let me expand that a little bit. So, and what I've said is I've set a failure threshold. Actually, I set a failure threshold of medium. I said anything that's medium should fail. And I can set that for different scope of my environment. I can set that individually for different pipelines. So that's the scope that I've set, and it's flagged that and says that failed that organization policy. So normally I'll fill the pipeline. So I'm checking for vulnerability, I'm checking for compliance. So then it pushes the image in the registry if that image passed. So that image gets pushed into the container registry, and then we get to the pre-deploy stage where I have some additional checks for my infrastructure as code file. So here I'm using Terraform to provision some storage containers, blob containers. And in that case, what it's going to do is it's going to use checkoff to do those checks. And in this case, it's found some security issues. It said you have managed disk that's been provisioned using this Terraform template, and the managed disk has been set with encryption set to off. So it flagged that to me. I can go fix that before we get to runtime, right? And it gives me information on how to fix that. In some cases, if you're using a premium tier version of this, it's actually going to automatically raise a pull request to fix some of this for you. So in this particular case, it's highlighted again some encryption issues. So things with my storage container that I'm creating, secure transfer is disabled. So it's flagging that to say insecure protocols can be used to connect to that storage account if you provision that. So at that stage, I can go ahead and I can fill the pipeline again. But if I go to the next step, doing analysis of the Azure HAM template that's used to provision things like SQL database for the application, and it just found an issue to say you're not enabling auditing for your database that you're provisioning, and it flagged that, and it says you've disabled encryption in transit, so that's not set to support HTTPS only is not set to true, so you need to go sort that out before you deploy that SQL to production. So it flagged those. I can go to sort those issues out, and what I'm doing at this stage is I'm helping my development teams get better at deploying secure services and secure applications, because I'm not giving them a set of 500 pages worth of documents to say these are the best practices that you have to read and follow every time. Of course, they're not going to read that. They have other stuff to do. But if what I'm saying to them is all you need to add these checks to your Azure DevOps pipeline, and this will run through what you're doing, and if it finds any issue, it's either going to automatically raise a pull request for you to fix those issues, or it's going to provide guidance on how you can fix those issues. Development teams don't like their pipelines failing, so you're helping to educate them without giving them a 500-page document. And they don't need to be switching context to find out what's wrong. From within their tool, from within their developer platform in Azure DevOps, they can examine and see all of these issues. So let's bring everything to a close here. So let's bring everything to a close. So the key points that I want to raise here is the following. So I can't find the slide for that, so I'm probably just going to talk about that. So key point number one is have a look at the issues that you're currently sorting out in production, right? And ask the question, how can I identify these issues in my pipeline? So have a look and make sure that you can detect about 80%, and you can only detect and remediate about 80% of the issues that you're having. Make sure that you can detect and remediate those issues in your pipelines before they get close to production. So I think that would be where I'll probably stop for today. So I don't want to drag this too far, but hopefully you got one or two things from that. If you want to have any conversations about this, feel free to reach out to me on LinkedIn or Twitter. I'll be happy to have a conversation about it. But if anybody has any question, I'll be happy to answer any questions.
Thanks, David. So we have a question from Alan. He asks if these slides are available anywhere.
So what I can do is I can publish them on my GitHub repo. So let me go ahead and see if I have it published already on my GitHub repo. So let me just quickly go check that. So let me check if I have it published already. So what will happen is that in my GitHub repo, if you go to my GitHub repo, so just search for David Okeyode, and typically I have a folder called presentations. So if it's not there yet, I will add it there. So I'll add the presentation link there. So I put them as PDF in this. So just check out this repo, this link, and I'll put the presentation there.
Okay, that's awesome. And I can, so it's just github.com/David Okeyode.
Yes, and then / presentations, you see that there. I'll put that in the chat window.
Oh, great.
Yes.
Thank you.
Thanks.
Perfect. And that's it, actually. We don't have any more questions, but if anyone has any questions, please feel free to share them on the chats. And as David said, these slides now are available on his GitHub. So please follow the link in the chats and you'll be able to download them or view them. I don't think, David, there's any more questions in the chat, but as I mentioned, this session will be available to view on the Reactor's YouTube channel within the next 24 hours. And please feel free to reach out to David on his LinkedIn or on his Twitter if you have any questions. Oh, we do have a question, David. From Kevin, and he says, are there any tools scanning bicep files or only after they converted to ARM?
So from what I know, a lot of the tools that are available, we only check them after they've been compiled to ARM templates. But I'm sure that in a few moments, some of the open source tools and other maybe Microsoft partner tools that are available will have support for bicep also. So, but for now, typically you have to convert that to that's going to be converted to ARM template, and then you do the scan at that point. But that's just, I know that's an additional step that's needed, but yeah, that needs to happen. But I'm sure that's going to happen.
Okay, brilliant. And then we also have just a couple of comments saying thank you. And yeah, so maybe we should give it like a few more seconds if someone wants to ask any questions. They might be typing.
Yeah, that's fine.
We have another thank you. And Alan says ARM TTK. So
yeah. So ARM TTK, yeah. So it's one that I've actually analyzed before in my. So if you go to one of my blogs, azurehangout.com, so I've analyzed like ARM TTK before. Let me go to ARM TTK very quickly. So let me go to azurehangout.com. So if you have a look at one of the previous ones, so I have ARM TTK analyzed. Again, that was in September 2020 that I did that. So there may be a few changes and a few improvements that has happened. So it's a good tool, but I did find like some, definitely, in terms of what it's assessing, there are some limitations, right? So I think if I have a look at the checks that it has, so the list of checks, you can find them there. So anyways, I'll share the link so you can see the analysis that I did for HAM-TTK in September 2020. But these are the list of the things that it's able to address. But what you see is that this is more towards like a best practices tool versus a security focused tool, right? And one of the other things that I think that can be improved is the ability to add custom policy check. So that's one of the things I like about Chekhov is the ability to add custom policy check if you're using like the bridge crew version of that. So because that becomes important because the APIs evolve all the time, and security advisory comes all the time. So then that becomes important for you to be able to add checks on the fly to say, I want to start accessing any templates that's been used by my developers that violates the standard going forward. So again, so I'll put the link to like the HAM-TTK one. I'll put that in the chat window. So I'll show you like the analysis I did for that about some years ago, and then you can sort of see the checks. There's a link there for the list of checks that it looks for.
Okay. Yeah. Alan says for checking the templates. Yeah.
Yes.
So that's what you mentioned before. Great. Thank you very much, everyone, for joining in on today's session. I have just put up a link to our meetup page. Please go and follow our meetup page so you can get all the information on all our upcoming events. Follow our Twitter, follow our YouTube, and obviously David's session will be available to view on our YouTube channel. David has just put a link in the chat, so please feel free to check that out. I'm just going to post it. Great. Thank you very much, David. We hope to see you soon at the Reactor again. With
hopefully in person. I'm not sure when the in-person event will start.
Yes, absolutely. So if for everybody, our Reactor London, we have a lovely space in Shoreditch, and we are not open yet, but we are hoping to be able to open soon so we can all have in-person events. So to everyone who are joining from all over the world, we will obviously have hybrid events. So even if David is streaming live from Reactor London, we should be able to view his session globally. Fingers crossed. But thank you very much, David. And I wish you all a lovely evening. And thanks again, David. Have a great evening.
Yeah, thank you very much,
See you again. Thanks.
Thanks. Bye, everyone.